In this short tutorial, I'm going to show you how a simple on-delay timer works in a Allen Bradley Micrologix 1000 PLC. I have this connected to a Micrologix 1000 right here with a set of input switches to simulate input conditions, and I'm connected to my laptop through a DF1 cable with RS-232 protocol. I'm going to turn back to my ladder logic editor so you can see this, and I'm going to start building my program. I'll right-click on the end rung to insert a new rung. Into this new rung, I'm going to put a contact. This contact is going to represent an input status to the PLC. So it's input, word 0, I'll just say bit number 2, just for fun. I've got 6 I can choose from. I'm just choosing it randomly. So I'll label this thing with a symbol. This is input switch. Over here, I want to place a timer rather than a customary coil. I'll go to my timer counter tool palette, and I'll drag down an on-delay timer. I'm going to attach that right there, and you see the on-delay timer appear in the editor. I need to assign a place in memory, a file in the PLC's memory for this timer to work. So I'm going to choose letter T for timer, followed by a 4 because that's the default file over here for timers. And over here I'm going to put a colon. I'm going to say timer 0. And I can call this whatever I want, but in this case it's going to be an on-delay timer. It also says what's the time base of the timer. For every count, what do you want it to be? 1 second or 0.01 seconds, or what do you want? So I'm going to choose 1 second just to make it easy. And my preset value. In other words, if I want my timer to count up to a certain amount of time and then take action, I'm going to specify that time delay in this preset value. Since my time base is 1 second, I'm going to enter a number here that corresponds to the number of seconds I wish this timer to delay. So let's make it a 5-second timer. And right now it's saying the accumulated value is 0. That's going to be changing as I activate the timer, so I'll just leave it at 0 right here. And I've completed the setup of my timer. I'll now verify my program and download it to the PLC. And call this file test. Place file, absolutely. I want to proceed with the download, switch to program mode so I can do the download. It's now downloading. And go back to run mode and online. So what happens here when I turn the switch on, my real life switch, I activate this, and you notice the timer is now timing. And when it reaches 5 seconds, the accumulator stops incrementing, and also you see this coil here, the done coil, energized. If I turn the input off, that will open up this virtual contact, cutting virtual power to the timer, and that turns everything off. So right now I do have a working timer that counts up to 5 seconds and then stops. When it reaches 5 seconds, it activates the done bit. But I'm not actually doing anything in real life. I'm not turning on any real lights or motors or anything like that, so I can change this. I can go back and edit my program, going offline to edit, and here I'm going to add another rung. And in this other rung, I'm going to insert another contact. So I'll bring down a contact. And I want this contact to be associated with my timer. So I'm going to give it the proper name. This is going to be timer file 4, timer 0, my bit delimiter, which is a / DN for done. I'll give it a symbolic name, timer done bit. So this bit will activate whenever the timer reaches its preset value. Now to have this do something in real life, I'm going to drag down a coil and put it on this rung and give this coil a name. I'm going to assign it to output, word 0, bit 0. And I'm simply going to call it output. I'll verify my program and then I'll download. So what this program will do is when I activate the input, it will activate the timer. This will time and count up to 5 seconds. When 5 seconds is reached, it will close that virtual contact, the one labeled done bit, that will send virtual power over to this coil, which will energize that output. So, activating the program, I'm going to turn my switch on right there. My timer is accumulating. When it reaches 5 seconds, you'll see the power flow through this bit and turn on that coil. When I turn my input switch off, everything stops. So looking at this on the actual PLC, here's what it looks like. Here's my input bit number 2, my switch right here. When I turn this on, you can see the light on the PLC corresponding to the input state. Now, because this is a 5-second timer, I'm not going to see the corresponding output light until that's been on for 5 seconds. So here we go. 1001, 1002, 1003, 1004, 1005. And my output turns on. When I deactivate the input, my output should immediately go off. So this is an on delay timer. It turns off immediately.